Well, good morning and welcome to your electric vehicle Q&A. Today is your opportunity to speak with our college mentors who are here to answer any of your questions about the lab, about what it's really like studying engineering in college. This is your opportunity, and I just want to remind everybody, these sessions work really well when you are engaged and have questions for our mentors. Please do not hesitate to unmute or pop your questions in chat. And today we have three amazing mentors. We have Sarah, Grace, and Maria who are here to lead, and I'm going to stop speaking because I know you don't want to hear from me, and I'm going to pass it off to Grace.
Awesome. Hi, everyone. Sarah is going to share her screen and we'll begin the session. Okay, awesome. So this is electric vehicles Q&A session, and we'll jump right into it. So to start, we'll begin with this following agenda. So initially, we'll introduce ourselves, our backgrounds, and our engineering interests. But then we'll go through the electric vehicles lab, just recap the main concepts and go through any questions that you guys may have. And then we'll finish off with the college Q&A session where you guys can ask any college questions you like, and we can provide you guys general feedback. Okay, so for introductions, I am Grace Mency. I am a student at Dartmouth College. I'm a rising junior studying mechanical engineering and minoring in human-centered design. At Engineering Tomorrow, I'm a college mentor, and I also was a part of the Q&A improvement project, just improving the format of these labs. And finally, in engineering, I'm interested in the mechanical field and also construction management.
Hi, everyone. My name is Maria Krug. I went to the University of Notre Dame. I actually graduated, and I majored in chemical engineering with a minor in business corporate practice for engineering. And so as far as my involvement with Engineering Tomorrow, I served as a college mentor. I helped create the drug delivery lab, and I also worked on the Q&A improvement project. And then some of my interests in engineering include engineering better medicines and research in drug delivery systems, which is the bio side of chemical engineering.
All right, hi guys, and to round this out, my name is Sarah. I'm a rising junior at MIT, majoring in biological engineering and minoring in computer science. I've been with ET for a few years and dabbled in a few things, including the bioinformatics curriculum and the Q&A improvement project. And my research over the past 4 or 5 years has really focused on leveraging biological mechanisms to our advantage to combat some of the world's biggest problems. So right now I'm interning at CRISPR Therapeutics, which is an immunotherapy company who is developing cell therapy to treat complex diseases like cancer, diabetes, and other important indications. And in the past, I've done research with bacteria, developing self-destructing mechanisms for eradicating harmful cells in the body and the environment. So now we can go into kind of discussing the electric vehicles lab. We're going to give you guys a brief overview, and then we're going to answer any questions that you have, and then we'll move straight into Q&A about college. So first off, we just want to get an idea of where you guys are in the engineering process so we can give you a more targeted set of advice. So if people could either scan this QR code on the top left or join in this poll at slido.com with the following code. You can just tell us whether you're in that initial brainstorming phase, you haven't really started making the vehicle yet, if you're in the designing phase, if you've started making your vehicle, or if you're testing your vehicle, you've already built it, you're just kind of trying to go through that iterative process and see if you can make it better. Dang, you guys are fast. Awesome, so we'll give this a few minutes to go through. So it looks like most people are kind of towards the middle end of the process, which is great. Maybe you guys can show us vehicles if you have any built already. But for now, I think we can move on. So we will start with first thing.
Okay, so just a general recap for those who also might still be in the brainstorming phase. The main types of batteries that are currently used in electric vehicles include lithium ion, nickel metal hydride, and lead acid. So the components that you were given in your electric vehicle charging station are the following. You have your battery, the battery holder, so you can put the battery inside of this holder, and the holder is ultimately what you can attach to your vehicle. The jumper wires, these can just be used when charging your battery, a diode, and a PV cell. So over here on the right-hand side, you can just see an image of how you would recharge your battery if you had to. So you set up your solar cell, which is powering your battery, then you place the diode next, which just prevents the flow from moving backwards. And so you ensure that the flow will reach the battery, and then you have your battery. If we have any questions on this, we can stop and go through, but if not, we can move on. Okay, awesome.
All right, next we'll talk about a recap of how you design your own electric vehicle. And so from the student interactive workbook, the overall objective of those slides in this lab in general is to first use a solar cell to charge a battery, and then use the charged battery to power an electric vehicle that you construct. And so the steps of this lab include first building that electric vehicle charging station Grace talked about in the previous lab. That is primarily to charge up your battery so you have something to power your vehicle. And the second step states use your charged battery to power a fan. And this fan is what will be the source of power to propel your vehicle forward. And so when this fan is connected to your charged battery, it will power on. And the last step is to construct your own electric vehicle from various materials that you come up with. And this will be propelled forward by your fan. And so when you're designing, just remember it might be helpful to draw out a diagram of your design before you build, because planning is really important in the engineering process. And you can click on those links or take a screenshot and look it up to watch further videos. And just remember, like, some materials you can use are cardboard or water bottles. Oh yeah, we have a question in the chat. What do you think are the best materials to use to build your electric vehicle? And it's definitely up to you, but I would think about what materials are not super heavy, because you might only have one battery to power your whole electric vehicle. And so you might not want to use some super heavy metal or something like that. So that's why popular materials are cardboard, plastic water bottles, styrofoam for the main body of the car. And then for the wheels, you can use ping pong balls if you just want to glide over the surface, or some people have used Lego wheels or bottle caps if you want to make those wheels spin. Oh yeah, Lauren had a question in the chat. I'm having trouble with my wheels. What tips do you have for materials of use for axles versus attaching the wheels individually? So yeah, great question. As far as wheels go, it all comes down to making sure there isn't too much friction, which would allow the wheels not to rotate. And so some wheels for just attaching them individually would be like ping pong balls, because hopefully there isn't too much friction. It's a pretty smooth surface, so it could glide over like a laminate table or something that isn't exactly a rough surface. So keep that in mind when you're testing too, if you have a smooth surface. And then for like axle wheels, you can use bottle caps, Lego wheels, or any circular shape. Just make sure that the axle doesn't rub too much on the hole in the wheel. And that comes down to making sure the hole is big enough in order for there not to be too much frictional force. And then another question, do you think it would be better to do a box shape or a round shape? And I don't think there's necessarily a better way, as long as the materials you use are lightweight and they aren't too bulky or like a big design, because keep in mind you only have one fan to make your whole thing move. So maybe keeping and minimizing your design while still allowing it to move and have like a sufficient design would be a good thought process.
Yep, we've seen people do boxes, we've seen people do spherical, we've seen people do triangular. It really depends on the weight and how aerodynamic you make your vehicle in the end. So for some ideas of what you could do, you can check out those links or kind of look at pictures from the student interactive workbook. And if we have no more questions about this slide, we can kind of move on to the last portion of the EV portion. So for those of you who are in that testing phase, you've already built your car, there are really two types of questions that you want to ask yourself. First, did I actually achieve the goals that I set out to achieve that Maria just talked about in the last slide? So did I use like inexpensive materials? Did it take a reasonable amount of time for my battery to charge? How well did the battery actually power the fan? How fast, how far did my vehicle go? Those are like basic questions that all engineers need to ask themselves after they do a project. But the other set of questions is kind of on the improvement side of things, because every time you do a project, there's always room for some sort of iteration to make it more efficient or less expensive. So what other materials could you use that may help your vehicle go faster, make the vehicle lighter? Or how can you decrease the amount of time it takes to charge your battery? So after you ask those questions, if you've got some time after your testing phase, you can kind of go back and see if you can implement some of those other materials into your original design and see if you can optimize that electric vehicle. And just to give a quick overview on the applications of this lab, electric vehicles are super popular right now. And that's because they are, there's a multitude of reasons why they are important. So first off, they're good for the environment. People have saved over 150 million kilograms of CO2 by using electric vehicles. They can be faster because they're lighter, they have better performance, and they also have lower maintenance. You don't have to have that other motor in there. There's actually an efficient electric motor inside these vehicles that keeps them going for longer. So for our last question, we kind of want to know, what type of vehicle are you guys planning on constructing, or did you already construct? We've seen people do a lot of things. So if you are excited about sharing, we would love to hear. Ooh, a boat. How'd that one work? That's awesome. Definitely, if you want to make a boat, you have to be careful that your wires and your battery don't hit the water. So if you're still in that designing phase and you want to, challenge your friends to see who can make the better boat, just be careful of submerging your materials in water. Make sure you've got a good flotation device. Car, okay, cool. Race car. Wondering if the race car goes faster than the cars. Awesome. Thank you, guys. I think that 8 is what we got last time, so we can move on. And if you have any more questions about the electric vehicles lab, feel free to stop us at any time. But for now, we're going to move into the final portion of our Q&A session, which Maria is going to explain.
All right, so now is your time to ask us any questions you can think of going back to the electric vehicle lab, or you can ask us questions about college or engineering in general. And so here is a list of sample questions to get your minds kind of rolling and thinking as to what type of question you are curious about. But this is a time that we're going to be super honest with you as we've experienced and are in college. So you can get our point of view on things you might be thinking about in high school because we were in your shoes as well at one point. And so to get the ball rolling, I will ask Grace, why did you choose your major?
Yeah, so I chose engineering because I was actually a part of a program similar to you guys in high school. We had an engineering and architecture program where we would take little trips into New York City and visit the women in engineering in certain companies and kind of see their day to day and talk about their experiences. And that always just kind of stuck with me. And on the other end of it, I do love math and science, and I didn't want to be a doctor, and I didn't really know where, my interests really lied until coming to college and realized that engineering was the perfect fit for me. Sarah, what about you?
Yeah, so I didn't really know I wanted to go into engineering either. It was more of I stumbled upon it after looking at what my interests were. So when I was a kid, I would always help my mom in the garden with her plants. And if any of you have ever worked with plants before, you know that they're very temperamental. And so I remember one spring we tried to grow our plants and they didn't end up flowering. So you can imagine I was this very frustrated 8-year-old wondering why I'd put in all this effort to grow my plants. I'd like watered them, fertilizer, sun, and they didn't grow. So I did a little mini experiment where I tested the effect of different fertilizers in different parts of my mom's garden. And we found out that the fertilizer we were using was actually the worst one. And once we switched, our plants grew like crazy. So at that point, I was like, okay, maybe science and experimentation can have an impact on not just my life, but the lives of the people around me. So then I started branching out. I did a bunch of stuff and anything that I found remotely interesting. I did physics, I did behavioral and social sciences, but in the end, I kept coming back to biology. And that's kind of how you guys know what you want to major in. It's the thing that when you've tried a bunch of other stuff, the thing that you keep wanting to come back to and lose sleep over. So now I guess we can go over and answer some of the questions in the chat. We've got quite a few. So the first one from Madeline, is it hard to balance school and social life as an engineering major? Maria, do you want to take this one?
Sure. So as far as balancing school and social life, college comes down to time management. And so you have a lot more independence in what you can decide to do with your day. But in order to be efficient and make sure you get done everything you need to for school so you can have fun socially, it's important to keep a planner and dedicate certain time throughout the day for your studies. And then also to stay and have a balanced life and have a healthy, balanced life, you definitely need to dedicate time to your social life too, because college is not only about learning academically, but also developing and making new friends socially. So yes, it can be hard at times, especially during, say, a test week when you have a few exams in different classes. Those weeks you might have to dedicate more time to studying. But if you practice the skill of time management and it gets better each year, I know I definitely wasn't as efficient as I could have been my freshman year. You can, in fact, balance the two, but you're going to have to find that certain mix of when you do what and when you work best in order to make your ideal schedule, because everyone's is different. Does anyone else have anything to say about that question? or we can move on to the next one.
Yeah, I think you covered it really
All
well.
right. So, what did you do in high school to prepare for engineering in college?
So I can speak on this a bit. So obviously, engineering in college, you are learning a new curriculum that you've never seen before. So I guess what would prepare you the best for just being ready to learn that is just being able to problem solve, not settling with the first idea that you come up with, but continuing to iterate and think about how you can improve things. And the other thing you can do is just try to put yourself in groups where you're working with other people and see, how you work with others, why groups work well together, because all of those types of skills are really helpful when doing engineering in college. It's hard to prepare for the material itself because it will be new when you first see it. But definitely, practicing those skills. Also, what I did is I took a lot of my math notebooks from high school with me to college. So don't throw them out in the fire when the school year is over. Try to hang on to them. I remember I took my BC calculus and my AP physics textbook and my own notes with me to college. And that was super helpful when just doing those intro math, chem, physics type classes.
Yeah, another one of the things that's super helpful is like time management skills. So when I got into college, some of the tricks that I learned worked best for me in high school, transferred over. So when I was in high school, I kind of realized that I'm a very visual person. I really need to see what I have due and what I have going on in front of me so that I can remember to do it. So I know some people, Google Calendar works really well for them, but for me, I just really needed my assignments staring me in the face all the time. So what I started doing was making liberal use of sticky notes. So I have this like wall during the semester with three sections: to do, doing, and done. And at the beginning of the week, I will take sticky notes and I'll put all my assignments that I have due for the week in the to do section. And as I'm doing them, as I'm working on them, I'll move them across the wall. And that's kind of how I keep track of what I've got going on, what I've already finished. And, by the end of the week, you've got some nice serotonin release knowing that you've done a bunch of assignments and you've finished everything successfully. So if you're a visual person like me, I would highly recommend doing something like that, or like putting a sticky note on your laptop so that it's staring at you all the time.
All right, I can answer the next question in the chat, which is, were you the only girls in your major? And so this is actually really cool for my class at Notre Dame in chemical engineering, but we were the first class where the female percentage was actually higher than the male percentage. But definitely in some schools, there might not be as many girls, or there might be a ratio which favors one side. But overall, I think as far as like women in STEM and engineering, there's a lot of programs like at Notre Dame. There is a Society of Women Engineers, which I think is at pretty much every campus. And there's resources to help you succeed and be in an environment with people like you. And I never had any negative experience. Everyone was really respectful and super open-minded and worked together with everyone in my major. So that was never an issue.
Yeah, I think Maria covered that really well. So we can move on to the next one. What is your favorite project you've worked on in engineering? So for me, it wouldn't be a project related to coursework specifically, but it's a project that I've worked on with a group outside of class. So it was about a 5-month project. I mean, it was carried over 2 years, but I was on the project for about 5 months. And basically what we did is we constructed a solar water heater for rural schools in Uganda. So basically using solar panels to heat up water in a tank that could be used for cooking throughout the day, because schools in Uganda currently only cook using firewood, which is really bad for the environment and just not sustainable overall. And so we were trying to make a new solution for a way to heat up water to cook. And so we went through a ton of design processes and testing and building on campus. And it ultimately got approved, and a few of my team members took it to Uganda this summer actually and built it and put it in, and it's actually working so far. So I mean, it was just a very cool project overall. We worked with a team of students from Uganda. We would Zoom them weekly, and it was just amazing to get to know them and talk to them and figure out how we could solve a problem together while we were quite literally like across the world at the same time. So it was just absolutely amazing and very impactful. So that would definitely be my favorite project. Sarah Maria, do you have a project you would like to talk about?
Yeah. We can kind of, I think all three of us can talk about it since we're all kind of in different fields. So this is a cool thing to talk about. I can talk about one that I did in high school towards my last 2 years. And it was essentially I would always go on walks around my grandma's pond, lake, whatever it was. And I remember one summer when I was taking my walk, there was an overgrowth of algae, and it was killing all the fish in the pond because it was sucking all the oxygen out of the water. So that was when I started this project to see if I could kill the algae in the pond while keeping the pond, without any toxic chemicals, and while making sure that the aquatic plants also stayed alive and the fish that were still alive also stayed alive. So I made use of this biological mechanism called programmed cell death. It's basically the reason that you guys have 5 fingers and not a blob of flesh is because when you were developing in the womb, the cells in between your fingers underwent this orderly form of cell death called apoptosis. So I thought, okay, well, if we have this kind of genetically encoded program in our cells, why would the algae not? Why would the bacteria in the pond not? So then I did some research, and I figured out that they actually do have a very similar mechanism. So in order to develop our treatment, we tapped into that and said, okay, let's make the algae kill itself. And it sounds, I think, easier said than done. There were a lot of iterations that went into this. There was a lot of research that went into this. And I think it was a very good example of the iterative process in engineering. The first time you do something, it's really not going to work out. Like the first time we did it, our treatment didn't even dissolve in the water. And we found out that it was because the compounds we were using were actually physically unable to dissolve in water. So we had to figure out how to put them in some vehicle that would make them able to attack the algae. And then the second time it didn't work, but the third time it worked like a charm. So that's kind of what you guys need to keep in mind when you're doing labs like this and when you're doing other engineering projects in the future. And Maria, do you want to round us out?
Sure. So one project that was kind of like a 4-year long project in college for me was that freshman year I joined this program called the Grand Challenge Scholars Program. And basically it's through the College of Engineering, and you can dedicate and research throughout your 4 years of college to solve one challenge in engineering that will help make people's lives better and easier. And so the challenge I chose is to engineer better medicines. And so with this challenge, there are different applications that I had to fulfill, like a business component, research component, social outreach. And so for my research component, I was an undergrad lab assistant in a lab that studied drug delivery systems and how to make them better. So that way, when treating something like cancer, the drug only reaches those unhealthy cells while not affecting the healthy cells, because that's what leads to a lot of negative side effects in patients. And so basically, I really liked this project because it introduced me to the realm of the pharmaceutical industry and what a lot of career paths I could do to continue this challenge outside of college. And so I'll be working at AbbVie next year as an engineer, and I hope to learn about this challenge like in the real world with my time there. And so looking at the next question, how is your experience actually studying engineering compared to your expectations? I can start out. I think my studies definitely like exceeded my expectations because not only was engineering really fulfilling because you're learning like how to problem solve in real world applications, but I think engineering is special because there is some sort of challenge to it, which brings you closer to the people in your class because engineering is very collaborative. Your teachers want you to work together. And with that, you'll spend numerous hours doing homework sets and studying for exams with those people in your class. And I know I formed a lot of great friendships. Some of my best friends were my engineering friends. And so I didn't expect this at all to form lifelong friends from my major, but I did. And that's what I love about engineering. Does anyone else have any further questions before we wrap it up?
Well, I'm going to hop in and I just want to say thank you to our amazing mentors for leading this great session. I want to say thank you to all the participants. You guys had some amazing questions and great engagement. Thank you again. And again, if you have any questions that you weren't able to get in this session or weren't able to answer or we weren't able to get to the answers, please feel free to email us and we'll get them back to you. And I'm going to stop the recording.